Hello, my name is Derek Cross. I am a student at Colorado State University Global Campus within the Ops 510 Operation Management course under the instruction of Dr. Melinda Hollingshed. This presentation is a discussion of inventory management and includes analysis of a simulated case study. Let's discuss the purpose and structure of this presentation. The purpose of this presentation is to explore inventory management and analyze a simulated case study. We will begin by defining what inventory management is and discuss why it is an important component of successful organizations. We will then look at a brief overview of the simulation and its goal before discussing the model and strategy used in the simulated inventory management scenario. We will then analyze the methods and techniques used throughout the simulation and compare the results to the stated goal before looking at the lessons learned throughout the simulation and the conclusions we can draw about inventory management as a result. First, we need to answer the following question. What is inventory management? In their book, Operations Management, Sustainability, and Inventory Management, Heiser et al. Write that the objective of inventory management is to strike a balance between inventory investment and customer service. Inventory is an important asset within an organization. It has a measurable value and can be insured. There are costs associated with holding inventory that affect its value over time. Managing these costs by finding the balance between holding inventory to immediately meet customer demand versus the cost associated with placing new orders and ensuring on-time delivery is known as inventory management. Within inventory management, there are 4 categories of inventory. Raw materials are one form. These items are inputs into an organization's transformation processes. Work in progress inventory are items that are currently in some stage of the transformation process, such as subassemblies. MRO inventory are the items necessary to keep the production processes running, items like lubricants for machinery or cleaning products for medical and food-grade processes. The final form of inventory are finished goods, the final products of the transformation process waiting delivery to the end customer. Inventory management is a critical piece of operations. At some organizations, roughly 50% of revenue may be invested into inventory. Alejo Reyes et al. Write that efficient inventory management is crucial for large companies and retailers as it directly affects profitability. Additionally, proper inventory management adds flexibility to operations. It can help anticipate and prepare for demand fluctuations, decouple production process components from sudden changes in demand, and take advantage of quantity-based discounts. The overall mission of inventory management is to reduce the costs associated with one of the biggest assets within an organization, its inventory. Let's take a brief look at the simulated case study. For this simulation, we were acting as the store manager at DigiLife, a consumer electronics retail store. A new device called the Amulet has just been released, and we were in charge of keeping proper inventory levels. Over the 1-year simulation period, we must balance holding costs versus setup costs, changes in customer demand due to online reviews, product recalls, and changing economic market conditions. Our ultimate goal is to reach $1 million in net profit by the end of the year. In order to accomplish this goal, let's take a look at the approach used to manage the inventory at DigiLife in the simulated case study. To accomplish our goal, we will utilize the economic order quantity model of inventory management. The demand for the Amulet is largely constant, at least week to week. The product has a consistent lead time with all ordered inventory arriving at the same time, and there are no discounts for larger order quantities. With these factors in mind, the economic order quantity model is an ideal candidate for this scenario. This model seeks to optimize inventory replenishment through the minimization of both setup and ordering costs. Before beginning the simulation, we were given the following information. The Amulet costs $95 per unit to produce and sells for $200 per unit. Each order has a setup cost of $6,000 and has a fixed 5-day lead time. Finally, holding costs like warehouse space and insurance will cost $1.35 per unit per day. Because this is a retail operation, we will assume that we have 365 working days each year. Using this information, we can find the optimal order quantity and reorder points for amulet inventory. The optimal quantity is the square root of the annual demand in units multiplied by the setup cost per order, divided by annual holding cost per unit, and multiplied by a factor of 2. A fully worked out of this approach can be found in Appendix A. Let's look at a few other methods and techniques used throughout the case study. The first method was to take the average weekly demand and convert it into an annualized demand. This metric changed every day, so by averaging the value over each week and updating our inventory forecast, we can stay ahead of large changes in demand. The second method was to use a one-day safety stock in case of mistimed orders. Because we had to order amulets only in multiples of 50 units, there would be occasions when an especially large shift in demand from one day to the next could potentially put us under our reorder point. So keeping a day of safety stock on hand would prevent this issue from escalating into a stock out situation. The final technique used in this simulation was the calculation of a demand-based reorder point. The basic economic order quantity model gives us number of days between replenishments, but this does not account for changes in demand during those periods. Taking the extra step to calculate the quantity-based reorder point gives us a fixed trigger point that changes with the current annualized demand. So by incorporating all of this information into our inventory management approach, how well did we perform over the 1-year period? As a reminder, the goal of the simulation was to finish the 1-year period by earning $1 million in net profit. In our case, we earned over $1,070,000 in net profit and sold over 13,000 amulet devices. One metric we were especially proud of is the 100% on-target rate. This means that all of our orders were of the optimal quantity based on the demand for the amulet, and never had excess stock that we had to pay holding costs on. We did have one stockout event, but it was due to an abnormally large demand shift from one day to the next, and due to our safety stock, we missed sales of just 16 units. An expanded set of simulation results can be found in Appendix B. What lessons can we draw from this simulation and the results? The first lesson this simulation revealed was the need for hypervigilance within inventory management. It is easy to let stock deplete to dangerously low levels, and unexpected demand spikes at these times can easily result in a stockout event. The second lesson from the simulation is how quickly holding and setup costs can add up. $6,000 per order and $1.35 per unit per day seem relatively small to the $1 million profit goal, but over the 1-year period ended up equaling 20% of the total expenses. The final lesson is how disastrous delivery delays can be for inventory management. It was a constant struggle to keep inventory at the optimal levels, and that was with a perfectly reliable 5-day lead time that never wavered. This really illustrated the importance of having reliable supply chain partners, as deviations in the quoted lead time would have made this simulation orders of magnitude more difficult. Now, let's look at some final thoughts on inventory management after the simulated case study. Inventory management is a critical piece of successful organizations. It has implication for cost reductions in one of the largest assets an organization owns. Gebisa writes that inventory management practices increase firm performance by improving product quality, reducing operating costs, enhancing customer service and customer responsiveness, and minimizing delivery times. Because so much of an organization's revenue is spent on inventory, minimizing holding and setup costs through replenishment optimization is a great opportunity to improve profit on an organizational level. Further information, such as an example of the economic order quantity model used, and the full results of the simulation will follow shortly in the appendices. Thank you for listening, and have a great day.